Hello guys, and once again, for the last time, welcome back. Pasok atras! Welcome back to our class here in Esci132, your Mechanics of Deformable Bodies. And this will be our last meeting, and fortunately, we have already finished all our topics, and kaning atong topic karon mo na lang ning last, and this will be the final topic sa atong third long exam. And currently, we are here at the Molave Hill. So I think you are not very familiar of this place because it is full of weeds and mao nang dili na ni familiar. Pero nakabantay mo anang dapit sa atong swimming pool. Atras, pagdali atras. Nakabantay mo anang dapit sa atong swimming pool, mao ni dapit nga lugar. Okay? And for our topic for this morning, we will still continue our topic on our 6th chapter, which was about transverse shear. And on our last meeting, we have started, and I have introduced to you the shear formula. Okay, and as you can remember, the shear formula, to get the maximum shear stress of a cross-section of a beam, all you have to do is to use VQ over I multiplied by the thickness. So, and karon, I left you a question last week kung how about if we are going to use fasteners like nails, like glue, or other kinds of fasteners. So, the question is, pila ka buok fasteners ang atong ibutang nga kuan para iya makaya ang kana nga load nga dalaan nga beam. Kay diba, usually we are using wooden planks in order to create our beams. And to use wooden planks sa atong pagpilit, we either use glue or we either use nails. And diha sa atong mga steel nga beams, we usually weld them or we use fasteners. Okay? So that will be our topic for this morning, which is the shear flow in built-up members. Built-up members means kanang members nga gifasten, kanang members nga gilansang, kanang members nga giglue. Those are composite bodies but built up sila, gifasten sila together. Okay? So that will be our goal for this morning, but we should understand the shear flow, unsa man ang shear flow, and we should solve problems which relate sa atong kanang to solve for the shear flow and to solve for how many number of fasteners or nails to be used sa anang atong pag-construct sa anang things, so whatever things, and na. Okay, so let's go directly to our topic. Again, what I've said earlier, usually when we do construction, when dealing with composite beams, we usually either use nails, use bolts, use fasteners, or use welding material, right? Or glue. And in order again to understand how many bolts you need or unsay amount sa shear nga kailangan para ma-resist sa anang atong mga bolts ang stress nga naa diha sa atong beams, then we should understand the shear flow. So basically kay di ba, when members are subjected to bending, they have the tendency to slide with each other. And in order for that to not happen, then these fasteners are used. Okay? So the magnitude of your shear flow is actually has the same concept dito sa atong transverse shear nga lesson, sa atong shear formula nga lesson. And take note that your shear force, your shear flow is denoted by the letter Q. Okay? So, timanay lang na nga Q ang atong shear force. Small letter Q. Ang atong big letter Q mo atong first moment of area. Okay? So, sige. How can you determine the shear flow sa atong member, sa atong composite nga member, sa atong built-up nga member? We have to consider this beam. Okay? And this beam has a thickness of dx. Okay? And kani sila natay duha ka mga planks nga gi-connect sa flange sa atong beam. Okay? And ang giingon dere, gigamitan daw ni siya og glue para mopilit ni ang kaning atong wooden plank diri sa atong flange sa beam. Okay. And if we are going to observe dira sa gipiltan diha sa glued nga section dira sa atong plank, makita ni nato. Okay? And as you can see, these are the forces that is acting on this section right here diri sa atong plank. Due to your moment on the left portion, due to your moment of M, you have a force of F that is acting on the other side, on this side of this plank. Okay? And on the other hand, there is sa atong pikas nga moment natay M plus dm. Therefore, there is also a force of F plus df that is acting on the right side of this wooden plank. And again, kung kanilang ang imong ipang tanaw when you are going to sum the forces, then that will not be equal to 0. But this again should be equal to 0. So therefore, there is a shear force, a shear flow of df diri nga portion, in which if we're going to sum this one, and this one, that will all be equal to 0. And this is what we are concerned of. This shear flow that is happening in this portion right here. Okay? So, how can you, aray, ako bugas, ouch. So, we have to look for your DF. And as you can remember dito sa atong lesson last week, we have created this equation. Sa sige nato pag-derive sa atong figures and sa atong mga equations, we arrived in this equation. Tau times T dx is equal to. Okay? So, naani sa atong last nga lesson. And we arrived in this equation. And ang atong goal ato is ato gi-relate ang shear stress dito sa atong shear force. But in this case, we are looking for the shear flow. Okay? And we know kung unsa ni siya. This is your shear stress, right? Kaning tau. And this one is your area, which is ang kaning atong thickness multiplied by your dx. When you multiply your shear stress by your area, you will get your shear force diri sa atong ani nga corner, which is ang imong df. Okay? So therefore, your df is just basically equal to this equation, dm over I integral of y dA prime. Okay? And again, as you can recall dito gyapon sa atong transverse shear nga lesson, sa atong shear formula nga lesson, this one can be further simplified if naatay well-defined nga section, cross-section. And again, this one is your Q. Okay? And now, because we are concerned of the shear flow of that area right there along the beam, so when you are talking about shear flow, ang ato ganahan mahitabo is ato pangitaon ng force per unit of length. Okay? Kaya for example, pila ang force ana per unit of length diha sa atong shear nga location. Okay, so unsaan man nato? So basically, all we have to do is to divide both sides by dx. Okay? Ya kanipod ato pod gi-divide og dx. This one right here, kani siya is your shear flow. Force over unit of length. Okay? And that is again denoted as Q. Okay? And as you can recall, dito sa atong shear formula gyapon, dm over dx is unsa man to? V. Ang kani again is your Q. So, VQ over I. So, this is basically the formula of the equation that will be used sa imong shear flow. Okay? Your Q has a unit of force over length. A V is, of course, that is a unit of force gihapon. Ang Q nimo, length to the 3. Kani, length to the 4th. So therefore, force per unit of length. Okay, so how can you get the spacing na sa atong fasteners? When you are looking for the spacing of a fastener, usually, given ang shear force nga makaya sa atong nail. Okay, and usually, that force is denoted as F. Okay, because we have this figure, your nail can carry a load of at least F in order to support these two bodies nga gisupport dira. Okay? And ang kani spacing nga akong pasabot, mao ning spacing nga akong pasabot. So mao ning spacing nga akong pasabot. So mao ning S, this is what we're looking for. Kung pila ka spaces nga ang kailangan para sa tong nails makasupport ana nga shear loads. Okay? So we have this formula na pod. If given ang imong F, then ang ato lang buhaton is to multiply Q and spacing. So therefore, to get the spacing sa imong imong nails or bolts or whatever, or fasteners, then ang imo lang buhaton is F over Q. And diba, your F is in newtons and your Q is in newtons per meter. So therefore, this is in meter. Understood? So, ganun lang. And also, take note of this. For example, if you have these 3 beams. So we have these 3 beams. Okay, and these beams are nailed dira, ginail sila diha nga mga portion ha. Diha. Okay? So, nakabantay mo nga sa ani nga beam, usa lang iyang connection. Sa ani nga beam, duha ang iyang connection. And sa ani nga beam, tulo ang iyang connection. Okay? Again, from the neutral axis lang na. Ito lang nagikuan nga from the neutral axis. Okay, kung ingana atong situation, what are we going to do? Ang atong shear force ang atong shear flow ma-distribute sa aning atong connections. So therefore kung ingana atong situation, ang atong gamiton nga shear flow is basically your Q. Dira. Kung usa lang ang atong connection. But if duha ang atong connection, ang shear flow nga atong kailangan is Q over 2 sa usa ka member. Sa usa ka part sa kaning atong member. Okay? And if tulo, then you will use Q over 3. Okay? So timan ina. So ang shear flow, kung duha ka connection, imo i-divide og 2 para kay ang atong shear flow duha may nag-support. Kung tulo ang atong i-divide. Okay, so ana lang. And to understand more on this topic, let's have an example. Okay, so we have this example. We have this beam, this composite beam that is constructed using 3 boards. Kani, of course, kani, and kana. Okay? And if this beam daw is subjected to a force of 850 kilonewtons, then we have to determine the shear flow at B and B prime. So we have to look for the shear flow at this black nga portions dire. Again, the formula for our shear flow is Q is equal to VQ over I. Okay? And since V is already given, this one is already given, we have to look for the Q and we have to look for the I. But before we can look for Q and I, we still have to look for the neutral axis. How can we look for the neutral axis? Again, your neutral axis is your centroid. So therefore, we have to look for Y bar. And let's say that we will base it from the bottom of our beam. Okay? So, unsa ra ganito? Y times A over A. So, ato isam. Sa mani? Una ta diri sa pinakababaw. So, that is, ang Y sa ato unahon, this is 300 plus 5. So, 305 times the area, which is 250 multiplied by 10. So, this is our first area. And kaning kaduha, since they are symmetric, they have the same shape, so we can just multiply it by 2. So, 2 times, ang distance ani, from here, so, this is 150, right? Kaya tunga sa 300. So, 150 ang Y, multiplied by the area of 300 times 10. Divided by the total area, the sum of the areas, 250 times 10 plus 2 times 300 times 10. Right? And then you will have your Y bar as 195.6 millimeters. Okay? So therefore, this one right here, your neutral axis or your Y bar is equal to 195.6. Okay? And now we have determined your centroid or your neutral axis. So, karon na pod, let us determine the moment of inertia of the whole beam. So, can you get the moment of inertia of the whole beam? Again, parallel axis theorem. Una ta sa first nga, una ta ani. So, B, what is your base? That is 250 times height of 10 cube over 12. Right? Plus, pilang area nimo? That is 250 times 10 multiplied by Y. Diba? Ang distance sa centroid ani padong sa atong neutral axis. So, kibaw man ta nga ang distance diri padong diri is 350 and ang distance diri padong sa neutral axis is 195.6. So, ato na buhaton. So, that is 305 minus 195.6 squared. Okay? Next. Plus, again, since they are symmetric kaning duha, have the same distance from the neutral axis and whatever, then we can multiply it by 2. Okay? So, that is 300, no. Base, which is 10 times height of 300 cube over 12. Plus, 300 times 10 multiplied by, so, 195.6 minus half of 300, 150 squared. And you will get your moment of inertia in meters as 87.42 times 10 to the power of negative 6 meters to the 4th power. Okay? Understood? Nga na lang. Ay, kibaw naman mo ani, kay this is the most basic part na sa atong pag-solve, kay ako na ni gisigi og balik-balik og tudlo. Okay? And now, we have solved for I, we have solved given ang V, and we have to look for the big letter Q. So, how can you solve for big letter Q? So, since we are concerned during a portion, so mao ni atong kwaon nga area, which is ang atong A prime B. Okay? So, therefore, that is equal to, what is your Y? The distance from your neutral axis to this point right here. Diba? To the centroid of this AB, which is 5 millimeters. So, that is 305 minus ang distance na po ani, which is 195.6 times your A, which is 250 times 10. Am I right? Am I right? Am I right? Yes, I'm right. Then your Q di is therefore 0.2735 times 10 to the negative 3 meters cube. So there you have it. And you get your Q. And we can now solve for the shear flow. So therefore, the shear flow, dirita, your shear flow is equal to, pila tong V? 850 kilonewton. Ang Q, 0.2735 times 10 to the negative 3 over ang I, which is 87.42 times 10 to the power of negative 6. And your Q is equal to 2.66 meganewton per meter. Are we done? We're not yet done because, again, take note, this is connected at 2 points. Kaning B o B prime. So, unsa ganito kung na-connect siya og more than 1, so we have to divide by the number of connections. In this case, duha sila. So therefore, your QB is equal to your QB prime, and that is equal to 2.66 divided by 2 meganewton per meter. That is equal to 1.33 meganewton per. And this is your final answer. Understood? So that is how you solve for this problem. Okay, so how about we have this beam? Ang kani nga beam, ang gipangayo na po niya kay ang shear flow ani nga portion diri. So, ato lang ni imagine ha, dili na nato i-solve, pero what will happen sa atong solution? Unsa may ma-change sa atong solution? The same shear force nga gi-apply diri, which is katong 850 kilonewtons. How about your Q? Will your capital Q be affected? Yes, of course, your Q will be affected because unsa naman atong i-consider nga area karon? Mao na ni nga area ang atong i-consider. And di ba kay Q is equal to YA prime. So, mao ni ang atong area, which is kaning AC, and then ang kaning Y mao ni atong Y bar prime Z C. Okay? Y bar prime C. Kadaghan ba ning Y bar prime sub C? That's just a headache. Okay, so ingana. So, sir, nganong dili man apilang tanan kay mao maning tanan unta nga kuan? Dili. Ang kanila nga portion ang ato i-focus nga i-tan-aw. Okay? And how about your moment of inertia? Mag-change ang moment of inertia because nag-change ang imong centroid. Okay? And ngano na-change atong centroid? Because we have a new member here. Okay? So, ngana lang. Then you can solve for your Q. But the same, i-divide gyud og 2 because it is connected at 2 points. Okay? So let's have another example. Okay, our second example is a box beam. Okay? This box beam is composed of 4 nga mga boards that are nailed together. And there is an 80 pound of force that is applied at the top of this box beam on a cantilever beam ni. So cantilever ni because this is supported by a fixed support at the end, at the left end, and an 80 pound of force is applied on the right end of this box beam. And given now that each nail can support a shear force of 30 pounds, so we have to determine the spacing of the nails diri sa atong B, spacing, ang kani nga spacing ni, and then ang spacing pod sa atong C pod nga part, which is na dito sa pikas. Okay? So, mo nang atong pangitaon. So, how can we solve for that one? Diba? We understood that we have this equation F is equal to Q multiplied by S. And this is what we're looking for. This is what we're looking for, the spacing. Because your F is given as 30 pounds. And your Q, we still have to look for your Q. Okay, so therefore, we still have to use the equation Q is equal to VQ over I. Okay? And, dali na ta. So, what is our V? Our V is basically the internal shear of whatever length dira. And we know that since you only have an 80 pound of force that is applied diha, so we will immediately know that all the internal forces, internal shear forces in this beam is also 80 pounds. Okay? So, therefore, your V is 80 pounds. How about your Q? Your Q and your I are the critical dire. Because, as you can see, basin magtuura mo nga, diretso-diretso rin ni pag-solve. Pero, di ba kay, as you can remember, ing-ani siya pagka himo ang atong cross-section. Okay. And we all know that the neutral axis is of course the half because this is symmetric. So therefore, this is, your y bar is equal to, pila man na, 3 plus 1.5. So 4.5. Okay. So let's look for the I, for the moment of inertia. Your moment of inertia, ang ato lang buhaton karon is the big square minus the moment of inertia of the small square. Okay, mo lang na ato buhaton. So that is equal to, the moment of inertia is equal to base of, sa big square sa ta, base of 7.5 times height of 7.5 cube over 12. Diba? Base times height over 12. And then, we're not going to use parallel axis theorem because the centroid is still located at the neutral axis. And this is minus. Minus kay hollow man. And that is 6 minus 1.5, that is 4.5. 4.5 times 4.5 cube over 12. And then you will get that your I is equal to 229.5 inches to the fourth power. Naminod na ko. I can't feel my legs. Okay. So, dito sa Q. Okay? Kay take note, maglahi ang atong Q diri sa atong B ug sa atong C. Ngano man? Kay diri sa atong B, diri ta nag-consider sa Q. Okay? Sa C, diri ta nag-consider sa Q. Unya, ang area ang naglahi diri. Diri sa tasa QB. So ang QB, ang ato i-consider nga area is this one. Okay? So mo na to gamiton nga area sa atong QB. Okay, let's solve for QB sa. So that is y, which is from here to here, that is 6.75 minus 4.5. Diba? Kay 6.75, you can sa base, niya minus sa neutral axis. 6.75 minus 4.5 and multiplied by your area, which is again this area. So that is 7.5 multiplied by the thickness of 1.5. And therefore, your QB is 33.75 inches to the cube. And your QC, so sa atong QC na pod, mao lang ni ato i-consider ng area. Okay, because we are focusing dire. Okay? So therefore, that is still 6.75 minus 4.5 multiplied by the area, which is 6 minus 1.5, that is 6 minus 1.5, 4.5 multiplied by 1.5. And your QC is equal to 20.25 inches cube. Okay? So, now we can solve for the small letter QB and QC. Okay, so, unsa man to? Una ta sa QB. QB is equal to VQ over I, which is 80 pounds multiplied by Q, which is 33.75 inch cube, divided by I, which is 229.5 inches to the 4. And your QB, we'll find out that your QB is equal to 11.76 pounds per inch. Okay? Wala pa tanong man because we're looking for the spacing. So let's continue to solving. And your QC is equal to 80 pounds times, pila tong QC nga dako, 20.25 over 229.5 to the 4th. Then your QC is equal to 7.059 pounds per inch. So take note of these values. So di ba mao ni atong QB. Pero dili raman ka na ang nag-hold. Bisag wala ni nakalansang diri, we still have to include this one. So therefore, we have to divide this one by 2. We have to divide this one by 2. And also, kaning atong QC, bisag usala na siya naka-connect dira, pero duha man na siya, then we still also have to divide it by 2. Okay? And this is 3.5295. And this one is equal to 5.88. Okay. And now, we can solve for the spacing. Lahi ang spacing sa tong B ug lahi ang spacing sa tong C. Of course, because they have different values. If they have the same values, then parehas unta ni sila spacing. Okay? Sige. So, let's solve for the spacing. Spacing sa B sa ta. Spacing sa B is equal to F over Q. QB. That is equal to 30 pounds divided by 5.88 pounds per inch. And that will be equal to 5.10 inches. Ato lang siya i-round off kay lisod man no mag-spacing tag 5.10 inches. So to make it more secure, to i-round off og 5 inches. Kay the closer the nails, the better, di ba? Pero ngano nag-solve ta ani para ma-maximize nato ang number of nails. Dili kay kung ato ra sobraan pod og butang ang nails, usi kwarta. Nya kung ato pod gipalayo og maayo ang nails, basta hindi na ma-support sa atong beam. Okay, so manang kailangan nga optimal ang atong number of nails. So, ito lang gamitan og 5 inches para mas-safe siya. Dili sa SC, that is 30 pounds divided by 3.5295. And that is equal to 8.5 inches. So, these are your final answers. Okay? So therefore, ang spacing nimo sa atong B, sa nail sa atong B is 5 inches and ang spacing nimo sa C is 8.5 inches. Ano lang? Ganito ka grabe ang atong pag-solve sa problem para lang makuha nato ang spacing. Naghigda ra si unggoy kaganiha. Ako na siya ibutang diri kayo magbarog. Okay, so for our last example, hayag na ko no. So for our last example, we have two cases. We have an I-beam nga diri sa tong case 1, tagsa lang siya ka nail, ay tagsa lang siya ka boards, tulo siya ka boards sa babaw sa ubos, and they are nailed at sa babaw sa ubos. Sa case 2, nag-inarte siya kay naapay duha ka pairs of boards nga gibutang sa babaw sa ubos. Pero they have the same cross-sectional area. But they only differ with the placement of the nails and the placement of these boards. And the nails daw are said to be spaced at 9 inches. And your nail can actually support a shear strength of 40 pounds. So therefore, your Q right here is 40 over 9. The question is, ato'y pangita ang largest nga vertical shear nga i-apply aning case 1 o case 2, which is siguro ay samok nga, I think move vertical shear dira ug dira, pilay V nga kailangan nato para ma-utilize nato ang kana nga strength sa atong nail, or maximum nga V nga pwede nato ibutang ana nga board para dili mo fail atong nail. Okay, so that's the problem of this problem. So we are already given nagihatag nga hint ang atong nail can support 40 pounds of load, and they are spaced 9 inches. So therefore, that is your Q. Okay? And now we have to look for your V, which is this one. Okay? Muna itong pangitaon, but first, let's look for your Y bar. Your Y bar can be simply determined because this is asymmetric sa baba ug sa ubos. Therefore, your Y bar right here is 2 plus 0.5. So your Y bar is equal to 2 plus 0.5. So that is 2.5. Right? Because that is the half of 5. Okay? And your I, you have to solve for your I. Your moment of inertia is equal to unata dire sila. So that is base of 3 times height of 0.5 cube over 12 plus the area of 0.5 times 3 times the distance from the neutral axis, which is 2.25, that is squared. And we have to multiply it by 2 because they are symmetric, para sang baba ug para sang ubos. And the other one is base times height, which is base is 1 inch, height of 4 inches, cube over 12. We don't have to use the parallel axis theorem because the center of this one is located at the neutral axis. Okay, so therefore, your I is equal to 20.58 inches to the 4th power. Ay, di pa din yung box kay di pa din final answer. Okay? So, we have already solved for our I, and we have to solve for Q. So, unsaon pag-solve sa Q? And take note, we have two cases. Ang first case, gibutang lang ang plank sa baba ug sa ubos. Ang second case, na pairs of planks nga gibutang sa isig ka kilid aning atong I. Ang atong web nga part sa atong beam. So, ari sa ta sa atong first nga case. Case 1. Okay? Ang Q sa atong case 1, is of course this one. Okay? So, morning area nga ito i-consider, and then ang Y is ang distance from the center to the neutral axis. So, the distance from the center to your neutral axis is 2.25, nagdisod na kog yaw-yaw, multiplied by your area, which is 3 times 0.5. And that is equal to 3.375 inches cube. So, mali sa atong case 1, atong Q, sa atong case 1. How about sa atong case 2? So ang ato i-consider ng area karon kay kani. Okay? Usa lang atong pilion. Okay. So sa case 2, ang atong Q2 is equal to 2.25 gyapon ay 2.25 gihapon ang distance niya and multiplied by the area which is 1 multiplied by 0.5. And your Q2 is equal to 1.125 inches to the cube. Okay? And now, let's solve for V at sa atong duha cases. Okay? So, V daw di I is equal to Q times I over capital Q. Sakto? Okay, so una ta sa V case 1. Pila ang atong Q sa case 1? Pwede ito nag-solve. Ay, day. So, 40 over 9. Ang atong I sa case 1, the same ragyapon, which is 20.58 inches to the fourth divided by your Q1, which is 3.375. And your VI is equal to, V1 is equal to 27.1 pounds. So, mao ni ang maximum shear force nga imong i-apply dito sa atong diri before ma-fail ang atong nail. 27.1. How about diri sa atong kaduha, katong daghan ay katong sa kilid, sa case 2. So, V2 is equal to 40 over 9 multiplied by I, which is 20.58 gyapon divided by 1.125. And your V2 right here is equal to 81.3. So therefore, you can conclude that the second case can support larger load compared sa atong first case. And it can support 81.3 pounds compared sa 27.1 pounds. But, nganong dili man nga na atong mga beams, nganong ang case 1 man usually gigamit sa atong beams. Kausik anig lansang siguro noon niya magsigig pag-cut, no? So, wag di siya practical nga nang case. So, manang usually siguro case 1 ang gamiton gyapon sa mga tao. Pero kung dato mo, then you can use case 2. Magbutang mo sa isig ka kilid, ilansang. It's up to you. Okay, so those are the 3 examples that we have sa atong topic karon. And I hope you already knew how to use the Q. Kay ang Q gihapon ang critical diri. Libog pangitaw ng Q, especially kung basta nga na ng mga cases. And finally, we are done sa atong first semester. So we are finally done sa atong mechanics of deformable bodies, and human na to ang tanan topics, and I hope that you have learned everything. And even though nga dili jud mo maka-remember sa katong mga topics jud, but I hope the concepts will still tickle in your minds, and you can apply it on the future. Okay? So we are now done. This will also be this will also be the last time nga mag-record ko, and I will be missing this activity. But I hope nga I was an effective nga instructor sa inyo, and I hope nga sa akong mga pagtudlo ninyo ani nga lecture nakasabot lang mo sa tanan nako mga gipang yaw-yaw. Even though our topic is really complicated siguro in some cases, but I hope that with the help sa ako pagtudlo sa inyo, mas nakasabot mo sa atong lesson. I hope nga na-enjoy po mo, na-enjoy mo sa atong klase, and unsa ba ang resulti? I will be missing you guys. And I hope to see you again on sa atong face-to-face. Unta mag face-to-face na ta. Kay nakahinumdum mo sa akong promise, diba? Na mo kay promise dito sa atong group chat. So ato lang to. So as a summary for our lesson for this morning, you have understood shear flow, and that is denoted by your Q. You also know how to solve for shear flow. And you also know how to solve for the spacing of your um, nails and fasteners and bolts. And again, we're done with the SEM. First semester done. First time of having our online classes is already done. And I hope nakalahutay ra mo parehas ako pagkalahutay sa akong record karon. And again, this is VSU. VSU misses you, and if you want a tour, puhon, I can give you a tour kung ganahan mo. Okay? So again, thank you. Thank you for your support. Thank you for subscribing to our YouTube channel, and sa katong mga wala pa naka-subscribe, please subscribe because we now have 97 subscribers, and hinatontang ha bisag mahuman lang ni nga SEM moabot na tag 100 subscribers. So, bye guys. See you again on the next one. Peace. Si Onggoy po, magbabay po si Onggoy. Bye! See you on the next SEM. Ko sa akong assistant nga very abdik kayo mag record sa among taping. Say hi, shout out. Wave sa camera. Hoy!